Yeah, good morning, everyone. I think today I want to tell you about containerization and the usage of the Perturbo in forms of the containers and about the usage of the Docker for this purpose. So as you discussed yesterday with Shane, an installation of Perturbo, it's a bit difficult procedure because Perturbo itself uses different packages such as LAPACK, Quantum Espresso, HDF5, and you should have all of these packages installed before the Perturbo on your machine. All of these packages has lots of additional parameters of installation. They strongly depends on the machine which you use. They strongly depends on the operational system which you use on the machine, and so on and so on. And for this reason, we developed two ways of installation of Perturbo in our lab. So first one is from scratch, as you discussed yesterday. So simply install each package one by one on your machine by yourself from the scratch. Second way is the usage of the containers and the usage code soft which called Docker. And this way we chose for the tutorials which you saw yesterday and for the hands-on session for today. That's why we discuss this way today a bit more in a more detailed way. So yeah, why it's interesting to use the containers. Containers help you to use the software and to install the software faster and to start usage actually the software also faster. We've have to avoid this long installation procedure. It's not a universal way of usage of the soft, but it can help you to understand how it's work and to make the first meeting with it, as well as help to solve to run some computationally not very intensive programs. For start, let's talk about the Docker and containers. So what is Docker? Docker is a set of platform as a service products that use OS level virtualization to deliver software and packages called containers. Simply put, it's a program. So it's simply a program which provides you chance to use the containers. So it's just a software, it's just a program, and it's one of the program which help you to use the containerization. But what is the containers? It's a more interesting question. In order to understand better, we need to compare the container with the ordinary virtual machine, which you see on the left part of the screen. No, on the right part of the screen, sorry. So yeah, this one. In case of virtual machine, what we have our infrastructure. So our computer, we have hypervisor, which regulate work of each virtual machine. And we have like several virtual machines. As you could see, each of these virtual machines separated from each other. They all independent from each other, and they can be run also separately from each other. So we don't interact directly with each other, only with usage of hypervisor. Each of these virtual machines fully independent, and as a result, they occupy lots of place in the memory, and they have lots of components which probably not as useful for you because, for example, you need to use, for example, Linux only for one purpose or only for one software. In this case, you can use containerized applications. In this case, which you see in the left part of the screen, we have also infrastructure for sure. We have our host operating system. So, for example, Linux or macOS on a computer. When you have this program which is called Docker, which help you to run these containerized applications, and you have several containerized applications. These applications they use the operational system, for example, Ubuntu, which use the kernel of the host operating system. And on the base of it, we add like several more instruments and our software which you actually want to use. So, for example, container for Perturbo contain the Ubuntu shell, Quantum Espresso with Vanilla 90 inside of it, HDF5 package, and the Perturbo itself. And all of it wrapped up into one container. As a result, you obtain already a pack with all the programs which you need and which you want to use, and you can run it directly from your computer. Accordingly, by running a container of this image, what is the image we will talk a bit later, or you can run it on your computer with usage of the Docker, or it's analogous. Also exists analogous which called Podman, which is suits ideally for the clusters, for example. And that's a way to avoid the compilation of the soft, which is nice because, compilation of packages can be long and relatively complicated. Let's talk now about the basic concepts. So first, the basic concept is the image. So image is like a mini OS which will be used. It's the images which we host on the Docker Hub. So Docker Hub is sort of like the GitHub, but for the Docker images. So on the Docker Hub of our lab, for example, you can find free repo. The most important is this one, which is called Perturbo. Yeah, the naming in the case of Docker Hub, it's a bit weird, but yeah, the first part is the name of the owner. So our lab Perturbo. Second one is the name of the repo, also Perturbo because it's soft. And also you have here different tags. So what's the meaning of this tags? This text means the way of the compilation of a Perturbo. So for example, GCC OpenAP means that we compiled Perturbo with usage of GNU compiler collection and usage of OpenAP. iFort means that it's serial compilation with usage of the Intel compilers classics. IFX means that it's compilation with the Intel compilers modern version, and so on. And you see that they are all a bit different. They all take different size, but they all compiled for different architectures of the computer. So for the ARM chip, which is M1 or M2 on Mac computers, or system architecture which called AMD 64, it's the same as x86. So almost our computer except the modern Apple computers. So yeah, from this stack we obtained the name of the images. So it's, yeah, in this way. So first part, as I told, it's the name of the owner. Second part is the name of the Docker repo. And after the semicolon, the tag of the image. So this name can be understood as the image of a Perturbo user from the Perturbo repo with the tag GCC OpenAP. Second important concept here is the container. So container is the instance of virtual machine which is created. It's inside of the container you make all the work. So it's the you create the container from the image and then work with them, interact with them, or produce some results with usage of the soft inside of it. Yeah, so how to understand the difference between the images and containers? I think the ideal comparison will be from the object-oriented programming with the class and the instance of a class. So inside of the class, we define all the parameter of the items which we will use. So we define like the structure of it, but we actually work only with the instance of this class, with the separated items. Here, idea is the same. You work with the containers, you run the programs inside of the container, but you define like the all properties of this container inside of the image. Also, a bit different usage of them. In case of container, you simply run them and use in your practice. In case of image, you can use them for creation of containers, but also you can use it as the preliminary step for the for some our images. So for example, in case of the Perturbo package, we use Ubuntu image as the base, and on this additionally install some our packages. Also, we separated our own image in two parts. First part is installation of Quantum Espresso and HD5. Second part is installation of Perturbo itself. The next important concept here is the volumes. So what's the idea? When you create your container and run it, with this container simultaneously, we create the volume. So it's the place where all the changes will be saved during your work with the container. But the problem is that when you delete this container, you lose all of this memory, as well as then you decide if you don't define, if you work by default with the volumes, you're not able to obtain this memory from your host machine. It's accessible only inside of a container, which is not great. And how to solve this problem, we will discuss a bit later. So that's all about the like sort of theory here. Let's try to run the Docker on our own computer. So for this purpose, you need to install Docker application on your computer. It's possible to do from the Docker applications, so from the Docker official page, this one. So here exists the button download, and you can choose your case. So it's Linux, Windows, or two types of Mac, Apple chip or Intel chip. Yeah, you can choose it and download. It should be relatively fast. And after the end of downloading, you should simply agree with everything which will be suggested for you. It's fine. Docker is a good program. It's fine to agree with it. And yeah, I think the procedure of installation itself is as always. And yeah, here's not something different from the installation of any other packages. When you install it, you need to run this program. And yeah, while it's installed, I will show you briefly how it looks like. So yeah, where it is? Yeah, here we are. This one. Yeah. So when you install this program, you will see this screen. So first one is, so on the first panel, you see here the containers. You probably don't see, you'll see here the empty list because you probably don't have any containers. Images, volumes, and some other additional stuff. So from this like Docker desktop panel, it's also possible to interact with the containers and images. Oh, it's not very open way to interact because it's more useful to do it from the terminal panel. It's more useful, it's easier, and yeah, there's lots of comment, and the general Docker interaction from it with the terminal, it's pretty easier. So yeah, it's downloaded, I think. Yeah.
Sergei,
yeah.
Can you turn on your camera?
Oh, sorry, I totally forgot about it. Yeah,
also,
sorry.
Just a general announcement. If you guys have questions like while you're going through it, feel free to just raise your hand. We don't need to wait till the end.
Yeah, it's true. It's true. And yeah, like we download it, then you need to drop it into the applications, and yeah, you'll be ready to run it. Yeah, I'll not do it because I already have installed the Docker on my computer. And yeah. So if everything installed in the right way, you need to open the terminal panel and run a command Docker. What you will see here is a relatively huge output. So here we see all the commands for Docker. So it's like run, exec, ps, build, push, etc., etc., etc. And some management commands which help you in the usage of containers, building your own containers, and so on. In general, Docker has lots of documentations and lots of like supplementary information. You can find lots of video on YouTube. So it's very friendly community, and it's possible to ask many questions there. So yeah, pretty nice software to use. So yeah, is everything going fine? Any questions with that?
I was able to access it on NERSC, so I think it's okay.
Oh, so yes. Okay, great. Ivan, everything is great on NERSC. Cool.
Sounds good. Thank you.
Yeah. So yeah, if everything with the installation of Docker is fine, we can move a bit further. So yeah, next thing when we run this Docker command is you can see the images which you have on your computer. So for this purpose, you run Docker images command. And in your case, it will be something like this. So you will see the repo from which it was downloaded, tag, image ID, when it was created, and the size. So I have one image on my computer right now from this repo with this tag, image ID. It's like unique number when it was created and the size of it. In your case, probably you will not have anything on your computer. You simply see like this line, repository, tag, image, created, and size. Also, you can see the containers which you have on your computer. For this purpose, you need to run command docker ps and additional parameter a. Here you see also the parameters already of the container. So it's container ID, image from which it was created, command. What is command? We will talk a bit later. It's interesting. When it was created, status, port, and names of this container. That's all. Yeah. So yeah, now you probably don't have any containers. So yeah, probably you'll see like only this line, and that's all. Now we actually need to clone the image from the Docker Hub of the Perturbo. For this purpose, you can go to this link and open Docker Hub of Perturbo. We also already saw it. Go to the panel which called tags and choose any tag by your choice. My suggestion will use this one. Why? First reason is that it's much smaller in terms of the memory. Second thing is that it's ideally optimized. It's much more optimized for the Apple computers, which is I see the of your case. And Second case, that it's work very well for both type of architectures of a computer, of a processor for AMD and for the ARM. So it could be a pretty universal choice. And also here we have OpenMP parallelization, which is also pretty nice. So in order to obtain this image, you copy this command just by press this button. So pull command copy it and copy it into the terminal and press enter. It should think a bit. Remember that you should have the Docker desktop command run during the work, because this like Docker daemons help you with the work with the containers. And you should see like this panel of downloading of layers of the image. So each image contains several layers. It's like several programs installed inside, and it's downloaded one by one. So it should take some time. It's fine because it's, as we saw, it's 1.55 gigabytes, which is a lot. Yeah.
So when I tried downloading the Perturbo iFort MPI, it downloaded to 20 gigabytes, and I don't know why it's that large.
Yeah, it's fine. So the problem is that first of all, we take some memory for the so first of all, it's compressed size, as you see. So it's compressed size of iFort MPI, it's more than 6 gigabytes. When it should do uncompressing, and also we should take some memory for like the interaction with the system itself. And yeah, in case if you use Windows, all of these iFort or IFX stacks are fine because many parts of these containers already inside of your system. But in case if you use Ubuntu or macOS, yeah, it takes lots of memory. And that's the case, which why I personally use this stack. For me, it's much more useful.
Wait, can you just so everyone's aware, in the original email that we sent you a couple of days ago, we sent a link to the GitHub repo where all of these instructions that Sergei is going over are available. I don't know, did you show them, or can you show them like how they're in the hands-on one folder from that GitHub repo?
Oh, yeah, sure, no problem.
Follow along on their computers.
Yeah, sorry guys, I forgot to tell about it. Yeah, so you could find it on the Perturbo-code, Perturbo Workshop GitHub. And here you need to go to the folder which is called hands-on one. And here it will be simply readme file with all of the information which you need to use. Yeah. So if you have any question, just ask me directly. That's fine. Docker can be a bit confusing on the first time. That's fine. I also spent lots of time in order to understand how to use all of it. So when you download the images, if the download was successful, you obtain something like this. What's next? And yeah, view summary of and all of it should be downloaded, extracted, and it should be fine. When you can run command docker images one more time and see this. So we obtained a new image which called Perturbo with a tag GCC OpenMP, unique image ID, when it was created, and the size of it. So yeah, when it's uncompressed, it's a bit bigger, but yeah, it's understandable. Inside of it, Quantum Espresso, which is huge enough, HD5 and Perturbo as well, and the addition for the system. Okay, and you should obtain something like that. Now we obtained our image. Now we need to run the container, and for this you need to run this relatively huge command. Let's simply copy it from the GitHub and copy it inside the terminal and discuss it a bit. So what is inside of it? Here we have lots of parameters. First one is docker run. It means like docker run for me container, please. It's the first parameter. Second one, V means for the volumes, which we talked about earlier. So in order to connect the memory on your operating system and the memory inside of the container, you need to like directly pass this command to a container. Something like, hey, please connect these two parts of memory. First part is your folder on your host operating system. Second part is the address inside of your container. If you connect volumes in this way, you will be able to work with the files on your operating system and inside of a container simultaneously. As well, when you will make any change, and even if you delete the containers, all the change will be saved in your host operating system, which is really helpful because it's a way for us to use of it. So we're able to run some calculations, close the container, delete the Docker from the computer and forgot about it, but we still will be able to have these results of calculations and work with them. So yeah, sure.
Can I two rentals for the same container?
Yeah, sure, it's possible.
But if I run this command twice, the second time it does not work.
Sure. Why? So yeah, I will talk. Give me like 5 minutes. I will come to this point. Okay. That's important. Yeah. That's a valid question. Thanks a lot. Second option here is which one is this one, which called H, and it means the host name of a container. So when you will run the container, by default, you will see something like the name of the user as user at some number. This number means just the ID of the container. It can be a bit confusing. It's not very helpful. So that's why we define this parameter in order to have the name of the host a bit more understandable. There is no serious influence on the work of the container in general, but it's simply helpful to see what's going on. Next parameter is RM. RM means that delete the container, then its use is finished. It help you to save the memory because each container occupies the memory on your computer, and we actually don't need to save it. So we can simply run it, obtain our calculations result, and delete it, which is nice. And the name of the container is this one. So it's by the default, each container has only the unique ID and the memory generated randomly. In order to have some meaningful name, you need to run this command. And that's why you can't run this command 2 times. Because basically, you try to create container with the name Perturbo, and then one more container with the same name. That's caused obviously error because you can't have the 2 Docker containers with the same name. That's prohibited. That's why it's not possible to do. Although you for sure can run Docker in one window, Docker in another window. And you're able to run, for example, Docker container and then obtain some information about it in the second window. That's fine. And the last parameter here is a Docker image name. So it's Perturbo, and tag which you chose. So for me, it's GCC OpenMP. Okay, so let's fix this command for our case. For this, I need to change the tag first of all. So I'll copy this and place it here. And also I need to change the name on my personal machine, on my host operating system. What should I do? I delete this address. I open my computer, find the documents with the Perturbo Workshop, copy the path to it, Command V. So this is my address of the folder with the workshop, and inside the container, I should find it by this address. Okay, let's press enter. It should think a bit, and we see nothing, which is strange. Why? Like it's not what we want. The problem is that how Docker containers runs by default. By default, the pipeline is following. Docker runs the container. Inside of the Docker, you have the commands which container should run in the end. In our case, it's been bash. And after the end of working of this command, Docker container finished their work and it's simply deleted. So basically what's going on right now, we run the container run bash, finish running bash, closing, deleting, that's all. That's basically not what we want. We for sure want to be able to interact with the container. We want to make several computations inside of it. In order to do it, you need to add this parameter, which called IT. It means interactive. It means that you will be inside of your container and you will be able to do some calculations inside of it. Let's add this parameter here. So I'll copy this command and add command which called IT and press enter one more time. Hooray, we're inside of the container. So we see this naming user at Perturbo-code. That's why we added this parameter instead of some random number. You can also open the new window in the terminal. Yes?
Do we need to do the step not including the IT?
No. It was just for show how it's going. So yeah, you for sure can run this command simply. So you can pull the image and run it from scratch, and that's fine. So you can open the second tab, run here docker PSA, and see that actually we have the Docker container with the name, with this container ID. It was created from the image GCC OpenMP. It's run the command bin bash. So that's what I talked to you about. So it's by default, it simply run this command, finish it, and that's all. When it was created, what is the status and the name of it? In our case, it's named Perturbo. So you inside of it, you inside the folder run, you can type ls. You see our folder workshop, you can go there. And we see all the materials of our workshop, which is great. In order to better understand, so if you want to use Perturbo, all you have to do is to type into a terminal perturbo.x. Let's try this. Perturbo.x. Yeah, we see that it's actually run the Perturbo. So program starts with a serial multi-thread version running on several processor cores. For sure, we don't have here any input. That's why we simply run it and that's all. So I can finish it. The same will be with the Quantum Espresso, for example. So we also see program PVSCF, serial version in this case, and it's waiting for input. In order to better understand what's going on with these volumes, let's try to do several things. So I will open terminal in my host machine, go to the folder with my workshop materials, workshop. So what we see here, I need to delete this one. Okay. So what we see here several materials. The same materials we see here. Cool. Let's create here some file by the command touch test volumes. Let's check ls. So we obtain this file. That's empty file with the name test volumes. Let's see inside of a Docker image. We see the same file. So we created the file inside our host machine, and we are able to see it inside of the container. Let's do renaming inside of the container. So let's do the different procedure. Let's rename it. So just copy this command and see what's going on. So we renamed our file test volumes to the name test volumes 2. We actually see what we have it. And let's check it on our host machine. The CVS changes as well. And I even can exit from the Docker container. We don't have this Docker container at all. I removed it. But if I will type the ls in my host machine, I will still be able to see the file. So that's the idea of volumes, be able to obtain the information from the Docker on your host machine and vice versa. Okay, let's return back to the container. Let's run it one more time. Yeah, we are here. Cool. Okay, so yeah, now you're basically able to run the Perturbo on your computer. You're able to work with it. You have all the software which is needed for you. So you have here Perturbo, you have here Quantum Espresso, you have here HD5. You're able to use Vim here as well. So it's installed for you. Python, pip installer packages, and some other supplementary stuff which can be useful in your work. Yeah. Do you have any questions for now about the installation, about the usage of it?
Running pw.x or Perturbo.x, I found program exception illegal instruction. What's the possible problem? Is it because of not loading any modules?
Sorry, could you repeat?
I got program exception illegal instruction.
Oh, can I see it? Sorry. Yeah.
So I run it and I got it.
Portal severe. Yeah, what image did you download?
The first one, i4.
i4 MPI. And your computer with the Intel chip.
Yeah.
Yeah, that's very popular case. So what's the point is that? The point is that we use, so like fast solution, download please another image from the time. So what's the problem? I will briefly explain. The problem is that in the building of the image, we use the soft from the Intel, which called Intel Toolkit. And the problem is that when the Intel created this soft, they made some serious mistake. And this soft works fine in case of Apple with the Apple Silicon chip. It works fine with the Windows and Linux, but it always fails in case if we try to use the MPI on Apple with the Intel chip. So I made a request about it on the Intel and they still trying to understand what's going on. So even if you try to compile simply like you download the soft from the Intel toolkit and try to compile very simple Fortran program with usage of MPI, it will obtain the same error. So it seems like they didn't optimize something sort of it. So if you download the iFort version, iFix version, iFort OpenMP version, DCC OpenMP version, it will be fine. But usage of usage of MPI with iFort will cause error. We saw it like 4 times in our lab, I think, on different computers.
Okay.
Yeah.
Oh, Sergei, just to clarify, I think we recommend the GCC OpenMP one, right? Because on Mac computers it runs faster and it's not that large.
Yeah, it's true. It's a general suggestion to use exactly this this image as the base. Yeah.
And how do you open another window on the same?
So I think that you can run sort of like I don't remember, to be honest. I think it's possible to run. Yeah, we need to check it by the Docker like curriculum sort of it. But yeah, I think it's possible to run it and probably like going inside of it. But basically, yeah, I think should be fine to work like from the one image. And yeah, if you need to obtain some like connect with the memory of it, yeah, you can go to the folder from your host machine. It should be fine. Yeah. Some other questions? Cool. If everything with the containers is fine, we can go to the Testsuite and discussion of the Testsuite. So even if you use the containers, it's possible that you have some problems. So we saw it like a moment ago. We have a problem with the image because of the problems with the connection of our container and the host software and host hardware. Also, there could be possible problems if you, for example, trying to make some changes into Perturbo, or if you implement some features into Perturbo. And in order to check all of the stuff, you need to use the Testsuite, which is distributed into the Perturbo PI package. Let's talk about it a bit. So as you discussed yesterday, Perturbo package provides 2 executables. First one is the Qt text. It's the soft for the post-process preliminary DFT, DFPT, and 190 calculations, and to create the APR file in format of HDF5. So it's basically the interface of interaction between the contours processor and the Perturbo. Second executable is the Perturbo.txt. It's the core executable of Perturbo. It's the heart of the Perturbo. It's the software you have all of these calculation modes for the computing of electron transport. And for the testing both of these executables, we provide the Testsuite inside of a Perturbo PI. And recommend to run this Testsuite in the cases, first of all, if you in order to verify that your code runs correctly after the download installation, as we saw a moment ago. Even in case of Docker containers, there could be problems. Second thing is that if you modify the source code which you made and you still want to see how it works, it's a good idea to run the Testsuite. And third thing, if you would like to contribute into the Perturbo public version, if you want to contribute into the general package, it's important, even it's obligatory to run the tests in order to double check that everything is fine and we don't have some confusion with the code which was there before. Yeah, that's about the description of the Testsuite. Let's run it. So in order to run the Testsuite, you need to have some reference files, you need to have input files, and so on. You can obtain them into a folder by this address inside of your Docker container. So I can just copy it and go to this folder. Type ls, and I see here input files, reference files, Python commands in order to run the tests, and so on. And also what I see here is the folder which called config machine. And we'll work with this folder a bit later. So basically running the Testsuite contains 2 main parts, right? Testing the Perturbo.txt and testing Qt-per.txt. And yeah, that's work with them one by one. If you plan to use, or if you plan to modify only Perturbo.x executable, which is very popular case, the Testsuite will automatically run exactly this test for several materials and calculation modes and check that it works as it should. To test the Perturbo.x executables, we need to define the configuration file. Let's work with that a bit. So I will go to the config machine file and make a copy of this file. Okay, so I see here a file which called config machine. Let's open it. Oops, sorry. Control C. Yeah, cool, thanks. And let's open it. Yeah. What we see here, first one, we see a parameter is called pert scratch. It's the name of a folder where will be saved all the files which is computed during the testing. Second section is computational info. Here we basically have all the commands which should be run. So for example, for the step Perturbo, we can run some preliminary commands like model load, export number of threads in case of the OpenMP usage, and running the executable. So this example provided for the cluster with the Slurm. Our case will be a bit more simple. It will contain only like this command. So let's fix it then, so we can delete downloading the module because we don't need it. We already have downloaded, and we need to run this to fix this command of execution. Okay, so now we have our file for config machine. We can return back, and actually we can run the tests. Yeah, and we see running of the tests. So we see how it's interactively working. So this option S can give us a chance to see what's going on. So basically we see, we see how it's going. So we see like path to the tests, we see how it runs the Perturbo, we see preliminary commands, and we see the output of the Perturbo. So we see that it's serial multi-threaded version, we see the calc mode, we see the output, and we see the comparison of the files. So the files which is produced on the base of the HDF5 right now, and the reference files, these two files, and we see that it's passed. So it's fine. And this test run for the 6 different materials, and I think in total there is like 44 tests. So it's like different computational modes for different APR files. And it should take some time, even in case of the powerful computer, even in case of the very well optimized software, it still takes some time. Even on cluster, it will take like a minute or two or something like that. Yeah, but it should be fine to run it on your personal computer. It should be totally enough memory and power on your machine. Yeah, do you have any questions on the running of the Testsuite? So basically, if you want to change the tests, or if you want to like make a test of some special material, you can do it. What you need to do is to, what you need to do is to add something inside of some test by yourself. So you can also provide the input files for the testing, you can provide reference files for the testing, and you also can add information about them into the files, into the testing folder, and you'll be able to test them. Also, what you could do is to like run the tests with some specific parameters. So if you can find the documentation of the Testsuite on the official web page of the Perturbo-Pi, and you see here some parameters of the Testsuite. So for example, the source folder, so where we can find the tests, tags of the tests, for example, like tests with some computational modes, which APR you want to run. For example, so like we have 6 materials, you can choose only one of these material or 2 out of 6 materials or something like that. You can run only one test by your choice. You can also additionally add special parameter which tell the Testsuite to run Qt testing as well, in addition to the testing of Perturbo.x. You can define the name of config machine, and you also can save all the computation information. So for example, if you choose the parameter key Perturbo, it will save all the outputs of this program, which can be useful in case if you want to understand, for example, how it's going. So to see the outputs, see the memory consumption, time consumption, and so on. By default, if the test is passed, then the information about the test is deleted from the folder, from the TMP, from the Perturbo Scratch folder. If a test is failed, then the information will be saved in order to check where was the error. And as you can see, in ideal case, if everything is fine, you should obtain the message like that. So we have 44 tests passed, 24 skipped. It's fine because we didn't check the Qt testing. You can obtain some warnings, which is also fine, and some internal warnings of the PyTest, and you obtain the time duration. So it's like 3 minutes or sort of this. Yeah, so this was the testing of the Perturbo.x. A bit more advanced thing is testing the Qt, and it's a bit more complicated and contains already several steps. Before I'll go to this section, do we have any questions? No. Okay, great. So yeah, if you want to check both Qt and Qt.x and Perturbo.x executables, for example, you installed a new version of Quantum Espresso, or you downloaded Quantum Espresso as well, and you want to check how is it work properly with the Perturbo sort of it. And in this case, you can run tests of these both executables. Testing Qt contains 3 different steps. On the first step, we run Perturbo.x testing as we made before. These steps tell us that the Perturbo.x works as it should. It provides accurate results. Second step is to run all the preliminary ab initio calculations from scratch. So as discussed yesterday during the tutorial session, we need to run a CF and a CF calculation, DFPT calculations, linearization steps, and we run all of these tests for one of the material during this test suite. And we obtain basically the APR file with usage of Qt.x. And on the third step, you run Perturbo.x second time and obtain the materials. Why the procedure is so complicated? The point is that the APR file you can obtain 2 different APR files from the same material, for the same materials, for the same input files, and both will be fine. They all could be right. Problem is that because of the gauge freedom, you can obtain different numbers, but they all will be valid. That's why we can't directly compare 2 APR files. We can't simply take 2 APR files and compare it one by one and see how the Qt work. That's why we need to run Qt, compute the APR file, and then with usage of this APR file, compute the results of the work of the Perturbo.x. If we know that Perturbo.x works fine, and if we obtain some error, we can understand, okay, Perturbo.x work accurately. If we obtain some mistakes, that's the problem of Qt. That's why we have this 3 steps procedure. So for the third step, we don't need to run all of the tests of Perturbo.x. We are able to run only several of them. So we decided to choose 3 main computational modes, PhDs, PPHMAT, and BENS, and run these computational modes for each of the material from the test suite. Yeah, why we decided to not run Qt.x test by default? Well, because it's very time consuming. You need to run all of the calculations from Quantum Espresso. You need to run the DFPT calculations, which is especially time consuming. And as a result, for example, here we see that the tests take 3 minutes, which is fine, but it's all tests for Perturbo.x. If you want to run Qt.x tests on the fastest APR file, I've chosen it for you, it will take 20 minutes. So it's already 6 or 7 times more, and it's only 1 APR file. For 6 APR file, you obtain more than 6 times bigger time, which is a lot. and which is not useful for many cases, because the most often case is that of usage of a test suite, which you made some changes into the Perturbo.txt code and try to check how it's working. That's why we need, if you want to run the Qt-per.txt tests, you need to add special parameter. So in order to run it, let's follow a very similar procedure. We also need to fix our config machine file. How we're doing it? We go to the folder config machine, remove the previous config machine file, copy new one, and make changes there. Config machine.yaml. So what we see here preliminary comments, which is also not important for us right now. We can delete them. Yeah, and we see computational info. Here we see that we have computational info for each step. So we make the SCF computations with like this command. So in our case, it will be simply this. So pv.x. We run phonon calculations with the ph.x. We run an SCF calculations, linearization step, which we will need. And we also have the commands for Qt-per.txt and for the Perturbo.txt as well. So yeah, this config machine also was created initially for the usage on the cluster. That's why it contains all this command of the slurm. So here we also need to delete the slurm command as run, but we save these preliminary command steps. And yeah, cool. So now we have all of these comments. We now have the comments of the OpenMP to define the threads, and we're basically ready to run the test suite. So let's return back to a test folder and copy this command here. So as I told you, testing of Qt-per is very time consuming. That's why I chose the most efficient APR file, apr.apr4. If you want to run it, we have like 10 minutes before next session. You can try to run this command, and I think it will take like a bit more time, basically 20 minutes, but you can start running it and check how it's going, if it's like works at least, and yeah, see the production, and then probably return back and see how it's going. So run it, you see what we obtain some output of the steps of this test suite. So where was the yeah, so we see here that we have this testing folder. So we make the tests on the APR4, we calculate APR4, and we make the test of Perturbo-txt once more. We collected these 7 tests and we start running them. So on the first step, we actually testing the Perturbo-txt as we made it previously, and we see that all tests are successful. And then we need to start our quantum espresso calculations. So we actually do our SCF calculations. When we make NSCF calculations, phonon calculations, linearization step, Qt-per step, produce our APR file, and make the tests of the Perturbo-txt with them. And yeah, it will take some time. You'll see a huge output of each of them. Oh yeah, and now we in phonon calculations, which will take like, I think, 18 minutes out of the 20. It's a long step, which is quite understandable. Yeah, so when you see that the test is passed, you be ready for next hands-on session, and you obtain the container on your computer with a Perturbo inside, which you can use in your work. As I told, it's not a universal solution. So because you need to supplementary run this Docker program, the software which is inside of the Docker container could be not optimized for your machine and could not optimally use the hardware of your machine. But it's still the solution. It's solution even for the HPC case. So for example, the NERSC has their own program for running the container, which is developed inside the NERSC. I think they work with the Podman from the Red Hat Enterprise. Podman is an analog of Docker as well. And you're able to run containers even on the HPC and use their resources, which is, as I thought, could be a good solution because you avoid this installation procedure, and it will be helpful also to check the error. So for example, as in case of the i4 MPI, so we solve the problem, we already know what's its cause. So it's easier to contact with the Perturbo development team to understand the error, because it can be something which we can check on our personal machine, which is great. So I think that's all I wanted to say about the installation of Perturbo.x, Perturbo with the container, about the containerization of it, about the Docker, and about the Testsuite. While it's running and while we have some time before the next hands-on session, I'll be happy to answer any questions if you have some. Thank you.